Now let's see the topic of transactions. So what is a transaction is? A transaction is a collection of operations that perform a single logical unit of work. So let's look at a transaction from the perspective of a bank database server. Now if you are looking at the operations or the logical work that a bank database will get, generally there are various things like this. Assume that this is the bank database server, okay, and it is going to get lot of requests asking to perform some operation. Now if you take any operation, you can think of it as if it is a transaction because it is a single logical unit of work. Now let us say there is a transaction T1, let's call it as T1, which is requesting the bank to transfer account from some account A to account B, right? Now we are trying to transfer some money from account A to account B. Then what is that we are typically supposed to do is take the account A and subtract it from the and subtract that amount from account A and take account B and add it to B and write it there. So what I mean to say is, let us assume that account A is having $100 or 100 rupees as a balance, and account B is having, let us say, 200 rupees as a balance. Now if I want to transfer 50 rupees from A to B, if I want to transfer this 50, then after the transfer, how much money will A have and how much money will B have is, A is going to get decremented by 50 rupees, which means you are supposed to have 50 here, and what is B going to have? B is going to have 50 rupees extra. Got it? This is what is supposed to happen by doing this logical piece of work. Even though it is a single logical piece of work, you might have to do it in various steps. Now what are the various steps involved in this is, first thing is you might have to read the data from the database, right? Now A's data and B's data, all this data will be present in the database. First you are supposed to read the data from the database, okay? So read the account balance of A. Right? Now by doing this, what we get is, we can see that the amount of the balance of A is 100, okay, and after that you are supposed to decrement A by 50 because 50 rupees is what you are trying to transfer, right? And after doing this, you might write the balance of A back. So what did we do? We have decremented the value of A and we have written it there. Now we should not stop here. What should we do? After deleting or decreasing the amount, you have to increase the amount in the B side, right? So that is the reason you have to read the account balance of B and then add 50 rupees to B, right? So why am I reading? Because I don't know what its balance is. Then only if once I know the balance, then I can increment it or decrement it and then write it back. Now by doing all these 6 operations, 1, 2, 3, 4, 5, 6, I'll be able to perform one single logical unit of work, right? So all these 6 are required. Now let us say you have transactions and all the transactions are coming to you and all of them are queued up, which means transaction T1 is there, transaction T2 is there, transaction 3, many transactions are there, n transactions are there, and if a process is going to execute, if one process is going to execute each transaction, then what happens is, if you look at the transaction from the process perspective, it is going to have 2 parts here. One part is certain operations require IO operations to be done and certain operations require CPU to be done. For example, this operation requires IO operations to be done and this operation requires CPU to compute it, isn't it? And this operation again requires IO. Why? Because I have to read or write the data from the disk, so which is going to be given to the disk and you might have to wait. So which means CPU will typically be idle when the process is executing these 2 statements, right? And when the process is executing this statement, CPU will get some work. And here also IO, and here also CPU work, and here again IO. So coming to databases, most of the work present in any transaction will actually be accessing the database, which means IO related work will be more compared to the CPU work, right? And now if you try to execute the transactions one after the other, then CPU is going to be idle for most of the time. right? Then how can I increase the efficiency of the CPUs? You can think of it from the perspective of a process, right? In the process management system also, we have seen that in operating system, when we are trying to manage many processes, if you have to increase the efficiency of a CPU, you should keep it busy as long as possible, right? Which means whenever one transaction is performing the IO, you should be able to give the CPU to other process so that it will be doing, it will be computing some work. So what I mean to say is, now if you observe it, transaction T1 looks like this. For some time it is going to do only IO, and then again it is going to do some CPU, right? Work on CPU, and again it is going to do only IO, and again it is going to do some CPU, right? So this is how transaction T1 is working. Now let us say there is other transaction T2 which is able to which has got some computation work. So then whenever your T1 is busy with IO, then you could schedule some other transaction T2, let us say, if it needs CPU here, and whenever T1 again needs the CPU, you just switch it, right? So this is called as switching. So giving the CPU to T1 for some time, which means giving the CPU to the process which is running T1 and then taking it back to T2 like this. So to T1 for some time and again for T2 for some time and again for T1. This is called as switching, right? So we can do this kind of switching in order to, let us say, this is going to be idle whenever it is going to be given to T1, and again when T1 wants to do IO, then you can give it for CPU, right? So whenever you do such kind of switching, you should be very careful, because there can be various problems because of the concurrent execution of the process. So we have seen in synchronization techniques that when more than one process executes, and if between these two processes, if there is some common data, if they are going to access something in common, then there might be concurrency issues, right? So here also it is most common that when you are dealing with databases, many of the transactions will have some common data to be working on, right? So then you might get some problem, right? So what are the problems you might get is, I'll just give you an example. Let us say one transaction T1 is trying to transfer some money from A to B, which means this one only. So which is going to read A, and then which is going to decrement A by 50, right? And let us assume that while this process is reading the data, there is other process or other transaction which has started and which is actually trying to withdraw the money from A. Now at this point, assume that because of some reason you have preempted the transaction T1 and you have started the transaction T2. Now at this point, if T2 tries to read the value of A, right, then what it will see is, if the initial value of A, assume that the initial value of A at this point is, let's say, 100 rupees. Now T1 is going to see that A is 100 rupees and T2 is also going to see that A is 100 rupees, right? Now let us say here you are withdrawing the money, let's say 25 rupees you are going to withdraw, A minus 25, right? So here you are transferring 50 rupees from A and here you are trying to withdraw 25 rupees from A. Then how much should be the balance? 25 rupees should be balance after T1 and T2 finishes their execution. But now since you have preempted T1 and started T2 in between, now what happens is, if you write the value of A here and then write the value of A here, right? So this one is going to write the balance of A as 50, because according to this transaction A value is now 50, and this one is going to write the value of A as 75, right? Therefore the final value of A here is going to be 75. After both these transactions, actually the amount has to be 25, but now the amount is wrongly shown as 75, right? So if you observe this here on the other side, even though you are going to read B and then increment B and then write B, it is not going to change the value of A. So anyway, A's value is going to be fixed at 75 only, right? So whenever you are going to interleave the transactions, there is a problem that you might get inconsistency, right? What is inconsistency? It is not correct. isn't it? So such problems are going to arise whenever you try to increase the efficiency of the CPU by interleaving the transactions. Now in order to manage all this, we need transaction management system. Now what is the main responsibility of transaction management system is whenever you are trying to interleave it, it should give us the same effect. See what happens if you had if there is no interleaving, you would have executed completely T1 and then completely T2, and then let us say if you have 3 or if you have 2 transactions, you would have executed completely T1 and completely T2. In this case you will get a correct answer 25, or you would have executed completely T2 and then started T1, right? Then you are going to get a correct balance of 25. Now because of this interleaving only, you are getting an incorrect answer, right? Therefore if you execute the transactions one after the other in a serial manner, then you are going to get the correct answer, but the efficiency of CPU is going to be hurt. And since you are going to get millions of transactions as a request to the database system, if you do it in this way, your system is going to be very slow, right? Which means the response rate is very slow. So you are not going to do this. Now you have to have a system which is going to increase the efficiency of the CPU, and at the same time it should see that the transactions are executing correctly even with interleaving, right? For that reason we need the transaction management system, right, which is going to do this concurrency control exactly the same way we did in operating systems, but we have to be much more careful compared to operating systems, right, because here most of the transactions are having some common data. Okay, let's see what are the properties that each transaction should be satisfying.